Hello everyone, welcome to our class. My name is Ko-Chen Lee. In today's sections, we will talk about the TCP IP. TCP IP is a protocol of transmission control protocol and internet protocol. It is the transport layer protocol in OSI layers. TCP provides connection-oriented communications for networking. And TCP IP is the backbone for Microsoft Windows networks. It is required for inter-network communications and for accessing the internet. Before you can implement TCP IP networking, you should understand IP addressing conventions, subnetting options, and name resolution techniques. The networking features in Windows Server 2008 are different from those in earlier releases of Windows. Windows Server 2008 has a new suite of networking tools, including, first, the Network Explorer provides a central console for browsing computers and devices on the network. Second, Network and Sharing Centers provides a central console for viewing and managing a computer's networking and sharing configuration. Third, the network map provides a virtual maps of the network that depicts how computers and devices are connected. Fourth, network diagnostics provides automatic diagnostics to help diagnose and resolve networking problems. And every device that connects to the internet uses a unique address called an IP address, which works very similar to a host location address. A piece of data called packets are transferred via the internet between machines, which in turn give us the fully functioning interiors workings of the online community. In order for two machines or devices to communicate via the internet, they must transfer these packets of data back and forth. Unfortunately, the data packets cannot be transferred if the devices do not each have their own unique address. So the V and the number 4 or 6 in IPv4 versus IPv6 refers to the related protocol version number. IPv4 is, of course, Internet Protocol version 4, and IPv6 is subsequently Internet Protocol version 6. And IPv4 and IPv6 are used in very different ways. IPv4 has 32-bit addresses and is primary version of IP used on the most networks, including the internet. And IPv6 has 128-bit addresses and is the next generation version of IP. When networking hardware is detected during installations of the operating systems, both IPv4 and IPv6 are enabled by default in Windows Server 2008. And you don't need to install a separate components to enable support for IPv6. And IPv4 is a connectionless protocol for use on packet-switched link-layered networks. It operates on a best effort delivery model in that it does not guarantee delivery, nor does it assure proper sequencing or avoidance of duplicate delivery. These aspects, including data integrity, are addressed by an upper layer transport protocol, such as a transmission control protocol. IPv4 addresses can be used in three ways. First, the Unicast. Unicast IPv4 addresses are assigned to individual network interfaces that are attached to an IPv4 network and are used in one-to-one communications. And second, Multicast. Multicast IPv4 addresses are addresses for which one or multiple IPv4 nodes can listen on the same or different network segments and are used in one-to-many communications. Third, broadcast. Broadcast IPv4 addresses are designed to be used by every IPv4 node on a particular network segment and are used for one-to-everyone communications. A unicast IPv4 address consists of two components. First, a network ID. The network ID or address identifies a specific logic network and must be unique within the boundaries. Typically, IPv4 routers set the boundaries for logical network. And this boundary is the same as the physical network defined by the routers. All nodes that are on the same logical network must share the same network ID. If they don't, routing or delivery problems occur. Second, a host ID. The host ID or address identifies a specific node on a network, such as a router interface or server. As with a network ID, it must be unique within a particular network segment. An IP multicast is a technique for one-to-many and many-to-many real-time communications over an IP infrastructure in a network. It scales to a larger receiver populations by not requiring prior knowledge of who or how many receivers there are. And multicast uses network infrastructure efficiently by requiring the source to send a packet only once. Even it needs to be delivered to a large number of receivers, the nodes in the network, typically network switches and routers, take care of replicating the packets to reach multiple receivers, such that messages are sent over each link or the network only once. The most common low-level protocol to use multicast addressing is User Datagram Protocol, UDP. By its nature, UDP is not reliable. Messages may be lost or delivered out of order. Reliable multicast protocols, such as Pragmatic General Multicast, PGM, have been developed to add loss detections and retransmissions on top of IP multicast. Multicast IPv4 addresses in the range of 224.0.0.0 through 224.0.0.255 are reserved for local subnet traffic. For example, the address 224.0.0.1 is an all-host multicast address and is designed for multicasting to all hosts on the subnet. The address 224.0.0.2 is an all routers multicast address and is designed for multicasting to all routers on a subnet. And three types of broadcasts are used. First, network broadcasts. Network broadcasts are used to send packets to all nodes on a class 4 network. For network broadcasts, the host ID bits are set to 1. For a non-class 4 network, there is no network broadcast address, only a subnet broadcast address. Second, subnet broadcasts. Subnet broadcasts are used to send packets to all nodes on non-classified networks. For subnet broadcasts, the host ID bits are set to 1. For a classified network, there is no subnet broadcast address, only a network broadcast address. Third, limited broadcasts. Limited broadcasts are used to send packets to all nodes when the network ID is unknown. For a limited broadcast, all network ID and host ID bits are set to 1. As you have seen, certain IPv4 addresses and address range have special uses. First, addresses 127.0.0.0 through 127.255.255.255 are reserved for local loopback. Second, the addresses 10.0.0.0 through 10.255.255.255 and addresses 172.16.0.0 through 172.31.255.255 and 192.168.0.0 through 192.168.255.255 are designed as private and as such as are non-routable. Third, on classified networks, the class A addresses w.255.55.255, class B addresses w.x.255.255, and class C addresses w.x.y.255 are reserved for broadcast. On non-classified networks, the broadcast address is the last IPv4 addresses in the range of IPv4 addresses for the associated subnet. And subnetting an IP networks can be done for a variety of reasons, including organizations, the use of different physical media such as Ethernet, FDDI, WAN, etc., preservation of address space, and security. The most common reasons is to control network traffic. In the Ethernet network, all nodes on a segment see all the packets transmitted by all the other nodes on that segment. Performance can be adversely affected under heavy traffic loads due to collisions and the resulting retransmissions. A router is used to connect IP networks. to minimize the amount of traffic each segment must receive. Anyone who works with computers should learn about subnetting and what it means. A subnet is a portion of a network that operates as a separate network. Logically, it exists separately from other networks. Even its host on those other networks share the same network ID. And typically, such networks are also physically separated by a router. This ensures that the subnet is isolated and doesn't affect other subnets. The subnet mask identifies which bits of the IPv4 address belong to the network ID and which bits belong to the host ID. Nodes can see only the portions of the IPv4 address space that aren't masked by a bit with a value of 1. If a bit is set to 1, it corresponds to a bit in the network ID. If a bit is set to 0, it corresponds to a bit in the host ID. A subnet mask must be configured for each IPv4 address. Nodes on both classifiable and non-classifiable networks have subnet masks. On a classifiable networks, all the bits in the network ID portion of the IPv4 address are set to 1 and can be presented in dotted decimal form as shown in table. And the slash and the number of bits in the network ID are referred to as a network prefix. Following list shown in table. For example, you now have two ways of detailing which bits are used for the network ID and which bits are used for the host ID. With the network number 192.168.1.0, and you can use either of the following to specify that the first 24 bits identifies the network ID. The first 192.168.1.0 and 255.255.255.0, or second 192.168.1.0/24. As the number of subnets goes up to a factor of 2, the number of the hosts per subnet goes down by a factor of 2. Because Class A, B, and C networks have a different number of host ID bits to start with. Browsing bits from the host ID yields different numbers of subnets and hosts. The technique is the same. However, each bit represented as a 1 in the subnet mask corresponds to a bit that belongs to the network ID. This means the value of each bit can be represented as shown in figures. Each bit's range is broken into different sections, and each section corresponds to the range of a related field in the packet. Header bit's range consists of 0 to 3, 4 to 7, 8 to 15, 16 to 18, and 19 to 31. This corresponds to the values 0, 32, 64, 96, 128, 160, and more for data. For examples of the ranges and their use, refer to tables. The IP payload is of variable size as well, ranging from 8 bytes to 65,515 bytes. Although most people will never use these information on a regular basis, it is very useful for understanding how to troubleshoot network problems. And there are two categories of IPv4 addresses. First, public. Public addresses are assigned by Network Solutions. Formerly, this was an inter-NIC and can be purchased as well from IANA. And most organizations don't need to purchase their IPv4 addresses directly. However, instead, they get IPv4 addresses they need from their Internet Service Provider, ISP. And second, private. Private addresses are reserved for Class A, B, and C networks and can be used without specific assignments. And most organizations follow the private addressing schemas as determined by their information technology department, and in which case they will request IPv4 addresses from the IP department. And as with IPv4, the most important things the IPv6 gives us is the IPv6 address. Although IPv4 allows for more than 4 billion networked devices, the world is running out of available IPv4 addresses. To resolve this problem, IPv6 used the 128-bit addresses, and this allows for enough addresses. And IPv6's 128-bit addresses are divided into 8 16-bit blocks, delimited by colons. And each 16-bit block is expressed in a hexadecimal form. With standard Unicast IPv6 addresses, the first 64 bits represents the network ID, and the last 64 bits represents the network interface. And although IP addressing works well for computer-to-computer communications, it doesn't work so well when you and I want to access resources. Could you imagine having to remember the IP address for every computer that you work with? This is why computers are assigned names. Names are easier to remember than numbers. When a computer has a name, you can type that name rather than its IP address to access it. And this name resolution doesn't happen automatically in the background. A computer process translates the computer name you type into an IP address that computers can understand. And domain name systems, DNS, is a database system that translates a computer's fully qualified domain name into an IP address. Networked computers use IP addresses to locate and connect to each other. But IP addresses can be difficult for people to remember. For example, on the web, it is much easier to remember the domain name www.amazon.com, then it is to remember its corresponding IP address 207.178.168.48. And DNS allows you to connect to another networked computer or remote service by using its user-friendly domain name rather than its numerical IP address. Conversely, reverse DNS or RDNS translates an IP address into a domain name. And DNS provides a distributed database that enables computer names to be resolved to their corresponding IP addresses. When working with DNS, it is important to understand what is meant by the term host, host name, domain name, fully qualified domain name, and name resolution. DNS additionally includes support for caching requests and for redundancy. Most network operating systems support configurations of primary, secondary, and tertiary DNS servers, each of which can service initial requests from clients. Internet service providers maintain their own DNS servers and use DHCP to automatically configure clients, receiving most home users of the burden of DNS configurations. All hosts on the TCP networks have what is called a fully qualified domain name, FQDN. The FQDN combines the host name and the domain name and serves to uniquely identify the host. For a host named CPL05 in the yahoo.com domain, the FQDN would be cpl05.yahoo.com. For host name ITserv17 in the tech.yahoo.com domain, the FQDN would be itserv17.tech.yahoo.com. When connecting to a host using the SSH client, for examples, you must specify the FQDN. The DNS server then resolves the host name to its IP address by looking at its DNS table. The host is connected, and you receive a login prompt. If you are using only the host name without the domain information to connect to a server, the applications you are running may not be able to resolve the host name. This can happen if either the DNS suffix search order in your computer's TCP IP properties is incorrect, or the DNS table is corrupted. In these cases, entering the host's FQDN will allow DNS to locate the server. Also, if you are trying to connect to a remote host that is not local to your internet service provider, then you will probably have to use the FQDN. For example, it's unlikely that a DNS server at IU will have a listing for remote hosts at another university or an unrelated ISP. And name resolution is the process by which host names are resolved to an IP addresses and vice versa. when a TCP IP applications wants to communicate with another host on the network, it needs the IP address of that host. Typically, the application knows only the name of the host it is looking for. So it has to resolve that name to an IP address. And the way the operating system resolves the domain name is based upon its configurations. For almost all operating systems, the default order for domain name resolution is as follows. First, host file. There is a file called a host file that you can use to convert domain names to IP addresses. Entries in the host file overrides any mappings that would be resolved via a DNS server. And second, the domain name systems. And this is a system used on the internet for converting domain names to their corresponding IP addresses. Your operating system will connect to the DNS server configured on your computers and have that server return to you the IP address for the domain name you queried it with. Third, NetBIOS. And this only applies to Windows machines and will only be used to map names to IP addresses if previous methods failed. And these methods will attempt to map the NetBIOS names you are trying to connect to with an IP address.